Hello students. Previously I have discussed about different topics of your chapter 1 physics, that is electricity. Different topics like your charge, electric field, electric potential, Gauss law. Today I am going to discuss about capacitance and the combination of capacitance in series and parallel. Okay. So our topic is combination of capacitors in series. In class 10, you have already taught the combination of capacitors, combination of resistors like this. What happen in series combination? All the instruments are connected in end-to-end manner. That means the ending of first resistor is connected to the starting of the second resistor. And if I will connect battery here, with the positive terminal of the battery, only a first resistor is connected, and with the negative terminal of the battery, only the last resistor is connected. Okay, like this, we have now capacitors. What happen in capacitance? Actually, you have already taught that a parallel plate capacitor contains two plates. One is your positive plate and other is your negative plate. So we have different capacitors like this. This is one capacitor. This is the symbol. This is the symbol of a capacitor. This is another capacitor, and this is our third capacitor. So let this has capacitance C1. It has capacitance C2, and this has capacitance C3. So I am connecting all the capacitors to an external voltage or external source, that is a battery having a positive terminal and a negative terminal. Okay, in series what happen? Current is constant. What constant? Current is constant. As current is constant, that is why charge is also constant here. The charge flows, let Q, in this circuit. So this capacitor C1 has charge Q, this capacitor C2 has also charge Q, and this capacitor C3 has also charge Q. All have same charge, but let the external voltage, external battery has potential difference V. This V is distributed among all the three capacitors. Here is your potential V1, here is your potential V2, and here is your potential V3. In our home, we are connecting different instruments like fan, bulb, heater, geyser, fridge. All are in parallel combination. Why? Because in parallel combination, the concept is reversed. What happened in parallel? The voltage is same in parallel combination. So that is why, in our Indian supply, the voltage is 220 volt, right? So in order to get the same voltage to all the instruments in our home, we are getting parallel combination in our home. But here I am discussing about the series combination. In series combination, the circuit is like this. So here is a capacitance C1, C2, C3, and the external voltage is V. So here Q is same, and potential changes. Okay, so this is the positive terminal of a battery of a capacitor, and this is the negative terminal of a capacitor. This is also the positive terminal of a capacitor, and this is also negative terminal, and this is plus, this is minus. So what happen in series combination? The positive terminal of one capacitor, the negative terminal of the first capacitor is connected to the positive terminal of the second, and the negative terminal of the second capacitor is connected to the positive terminal of third, and in series charge is constant but potential changes. Okay, so now I will find the resultant capacitance or the equivalent capacitance of this circuit. Using this formula we will do some numerical problems which may some probable questions which may come in your board exam, or in entrances also come different questions, different configuration using this capacitor problems. The net capacitance is asked. Okay, so this topic is very much important from your exam point of view. So here potential varies, so I can say total potential at V, so V equal to V1 plus V2 plus V3, because we have 3 capacitors. Okay, so we have the formula capacitance C equal to Q by V. We have this formula C equal to Q by V, and from here I can write V equal to Q by C. So I can replace here this V equal to Q by C. Here V1 is equal to Q by C1, this is your Q by C2, and this is your Q by C3. Okay, so I can write here CS, S for series combination. Okay, here Q all are same. Okay, so I can cancel Q from both sides, so final answer will be 1 by CS equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is the formula for equivalent capacitance in your series combination of capacitance. Okay, so in series what happened, let we have 2 capacitance, then what will be the answer, what will be the net capacitance? Let we have 2 capacitance, then 1 by CS equal to 1 by C1 plus 1 by C2. So actually the reciprocal of the equivalent capacitance of this circuit is equal to the reciprocals of individual capacitance. This is called the principle of capacitor in series. Okay, so what happened here, if I take LCM C1 and C2, so here is C1 plus C2, so that is 1 by CS, and finally CS is C1 C2 divided by C1 plus C2. So if you check, let one capacitor has capacitance 2 microfarad, let, and the second capacitor has capacitance 3 microfarad, let. Then if you put the value here, let C1 equal to 2 microfarad and C2 equal to 3 microfarad, then the answer will be 2 into 3 divided by 2 plus 3, so that is 6 by 5, so that is 1 point something. Okay, so this value is less than 2, and this value also less than 3. So this is one property of your series combination. What happens in series, the total capacitance of the circuit is less than the individual capacitance. Okay, so here the value 6 by 5, it is less in comparison to 2, and the value 6 by 5 also less than the value 3. So this happen in case of series combination. If we have some identical capacitors which have same capacitance, let we have 3 capacitance, all have capacitance C. So then I can write 1 by CS equal to 1 by C plus 1 by C plus 1 by C, so which is equal to 3 by C, so CS equal to C by 3. For 3 capacitance C by 3, for 4 capacitance C by 4, for 5 capacitance C by 5. In general, for n capacitance CS equal to C by n. All clear up to this? If you have any doubt, then you can ask me. Okay, for n identical, this formula is useful for identical capacitors. For identical capacitors, all the conditions of series will be reversed in case of parallel. If I go to the combination parallel, then the circuit is like this. In parallel, what happened? Like terminals connected together. So here is all the positive terminals of the capacitor are connected together, and all the negative terminals of the capacitor are also connected together. This is your parallel combination. Parallel combination looks like this. Okay, so here is your battery having potential difference. Here is your battery having potential difference, let V, and it has capacitance, let C1, it has C2, and it has C3 capacitance. Okay, so what happened in your parallel combination? In our all the resistors, I am saying that in your house, already I have said, in your house all the household materials are connected in this manner. So in your all the in parallel, what happened? In series there is end-to-end connection, but here no end-to-end connection. All the first terminals are connected to the battery, and all the next second terminals are also connected to the battery. This type of combination is known as our parallel combination. Okay, so in parallel, what happened? V is constant, V is same, but your charge is different. Here let charge flows Q from the battery, so to this terminal charge goes Q1, to here charge goes Q2, and to here charge goes let Q3. So finally I can write total charge Q here equal to Q1 plus Q2 plus Q3. So as we have the formula C equal to Q by V, so Q equal to CB. So in this place I can write CB, in this place I can write C1V, in this place C2V and C3V. So finally our final answer is P for parallel. So our final answer will be Cp equal to C1 plus C2 plus C3. That means the total capacitance or the equivalent capacitance in your parallel combination is equal to the individual combination of, or the sum of the individual capacitors of this circuit. Let we have two identical capacitance, then Cp will be 2C. If I have three identical capacitance, Cp will be 3C. If I have n identical capacitance, then Cp will be Nc. So this is our answer. And one property of this parallel combination is, let one capacitance is 2 microfarad and other capacitance is 3 microfarad. Okay, so if I will get total in parallel combination, then it will be 2 plus 3, the answer will be 5 microfarad. Farad is the unit of your capacitors, and this value is greater than 3 and also greater than 2. So the properties, the total or the equivalent capacitance in case of 5 farad, 5 microfarad, this is 5 microfarad. So the total capacitance in case of parallel combination is greater than individual capacitors connected in that circuit. Okay, so this is the final formula for the series and parallel. Now we will do some numericals using this formula, some probable questions which may come in your boards and also your other entrances like JEE or NEET. So this formula is important. Like capacitor circuits, you have also resistor series parallel circuits. But what happened in your resistor circuit, both the formulas are reversed. In resistor series, what happened, all the resistors are combined like this, like some. In parallel it is reciprocal, so 1 by R1 plus 1 by 2. This is the difference in your capacitor and resistor. But the methods to solve the numericals or the different circuits both for same, for resistors and for capacitors. So I am giving you one circuit like this. This is one capacitors, this is one, so this is an infinite circuit. This is an infinite circuit, and the total capacitance is 1 microfarad here, and here 2 microfarad, here is 1 microfarad, here is 2 microfarad, and here is 2 microfarad. Okay, sorry, 1 microfarad. So I have to find the total capacitance of this infinite circuit. Okay, for small circuits you can use the formula Cs equal to C1 plus C2, 1 by Cs equal to 1 by C1 plus 1 by C2, and for parallel Cp equal to C1 plus C2. But for infinite circuit, what is the method? So it is an infinite circuit and it has huge number of capacitors. Okay, so for in entrance you do not have to calculate this. Direct answer will be this 2 microfarad. If this type of infinite circuits come in your exam, then you will check, you have to check if the capacitors in the middle have the capacitance is half of the capacitance of the top, then the final answer or the final resultant capacitance of this circuit will be 2 microfarad. Okay, what is the process? The process is let the total capacitance of this circuit is C. Let the total capacitance of this circuit is C. Then we have this is a branch, this is a branch, this is also another branch, then also another branch, then also another branch, like infinite branches are there. From infinite branch, if I will skip one branch, then there will be no problem. So let the total capacitance is C, and I am skipping one capacitance is here, and the total capacitance here is C. So this is the circuit. This is the 1 microfarad, and this circuit is our 2 microfarad. Okay, and the total capacitance up to infinite circuit will be how much? C. So now this 2 and C are in series. This 2 and C are in series. So what happens series? The formula I have already taught previously. So Cs equal to C1 C2 by C1 plus C2. So if I will put in place of C1 2 microfarad and in place of C2 equal to C, then our answer will be 2C by 2 plus C. This will be the answer. And so this is the resultant capacitance of these two capacitors. Now the resultant capacitance of these two capacitors will be in parallel with this 1 microfarad capacitance. So our total capacitance, that is parallel, equal to 1 plus that value to C by 2 plus C. The total capacitance of this circuit will be equal to the total capacitance of this circuit will be equal to 1 plus 2C by 2 plus C equal to C. So one is your series and other is your parallel. So our final combination is this, because I am skipping one circuit from the infinite, and if I will skip one circuit, then there is no problem. So now you will take the LCM and find the C. So this is a quadratic equation. So we can solve. So LCM is our 2 plus C. So here 2 plus C plus 2C. So here is C. So I can cross multiply. So from this to this side. So what will happen? 2 plus 3C equal to C whole into 2 plus C. Okay. So our final answer will be 2 plus 3C. So 2C plus C square. So now this is a quadratic equation. So you can make middle term break and you could able to find the value of C. Here if we'll take from the LHS to RHS, the final answer will be C square plus 2C minus 3C minus 2 equal to 0, and C square minus C minus 2 equal to 0. So this is a quadratic equation, and you can find the value of C by using your quadratic equation formula, minus B plus minus B square minus 4AC root over divided by 2A. Okay, so you can do the sum and give me the answer.